Alright, so today we'll be looking at m to the power 6 minus m to the power 3 equals 2. So let's solve it. Alright, so to make the work easier, we're going to say m to the power of 3 all to the power of 2 minus m to the power of 3 equals 2. We're going to say let m to the power of 3 be a particular letter. I'll be using y for this one. So we have y squared minus y equals 2. We'll be moving the 2 to the other side to make it look like a quadratic equation. So when it's coming to the other side, becomes a negative 2 equals 0. So there'll be no need of using the formula method for this one because it's quite easy. We could figure it out using minus 2 plus 1. And so we substitute into the quadratic equation and expand. Then we factorize by grouping. We'll be grouping y squared minus 2y and y minus 2. So we find out what's common, and we have y. When we factor that out, we have y minus 2 plus 1 into y minus 2 equals 0. Now we have two same parameters inside the brackets. We're going to factor out 1. So we have y minus 2, and we just pick one of it and then fix the other ones outside the bracket in a bracket, y plus 1. So we have two equations equating to 0, y minus 2 equals 0, y plus 1 equals 0. When we solve further, we'll have our y to be 2 or minus 1. Now remember that we said let m to the power of 3 be later y. So since we have the values for y, we're going to be solving to get the values for m. So since m cubed is equal to y, wherever I see y, I'm going to start with the first one, which is 2. So I'm going to move the 2 to the other side to meet its partner. So we have m to the power of 3 minus 2 equals 0. Now 2 there is having power 1. The only way we can get that power 1 is saying 3 over 3, just so we have an equation that looks like m cubed. Alright, so we factor out 1 over 3 and leave the cube outside. That's how it's shown in the video. Alright, so right about now we're going to use the expansion method we were taught in school. A to the power of 3 minus b to the power of 3 is expanded in this form: a minus b in bracket and another bracket a squared plus ab plus b squared. So using this, we're going to expand that. So wherever I see a, I'm going to put m, and wherever I see b, I'm going to put 2 to the power of 1 over 3. Alright, so at this very point, if you know you've been gaining value, please do well to subscribe to this channel, hit the notification bell, follow us on this channel. All we do here is maths. We solve questions. Alright, so let's jump right into our video. So we expand as follows, substituting each value in the bracket and then close it up. So remember that all of this is equal to 0. They are equal to 0. So it simply means m minus 2 to the power of 1 over 3 is equal to 0, or m squared plus 2 to the power of 1 over 3m plus 2 to the power of 2 over 3 is equal to 0. Now remember our question says m to the power of 6. So we're expected to have 6 solutions for m. So right here in the first one, we already have one solution for m, which is m equals 2 to the power of 1 over 3. Alright, So the other equation, which is a quadratic equation, will definitely give us two answers, two solutions, making it up three solutions already. And remember from the question, they said real solutions. They do not want imaginary solutions. So the equation on my left hand side will definitely give us two imaginary solutions. So we are not going with that. And so we're going to leave it and move to the next case, which is case 2, where y is equal to -1. All right. So if y is equal to -1, remember that m cubed is equal to y. Remember that m cubed is equal to y. So we will substitute. All right. So we'll move the -1 to the other side, making it +1 equals 0. Now, just to make it look like m cubed, we're going to say 1 cubed, which is the same thing as 1. Okay. And so we're going to use the expansion we taught in school, which is a cubed plus b cubed equals a plus b. In another bracket, a squared minus ab plus b squared. All right. So we're going to use this to expand that. So wherever I see a, I'm going to put m. Wherever I see b, I'm going to put 1. Very easy. So m plus 1 and m squared. Oh, that was a mistake there. That was a mistake. That was a mistake. Please pardon me. It was supposed to be minus m dot 1. It's supposed to be minus m dot 1. So sorry about that. This is a voiceover, so there's nothing I can do right now. Although we're not going to really work with the answers we'll get in the m squared plus, which is supposed to be minus. We won't work with the answers there, so that is a lifesaver. So the solution wasn't really correct because we omitted the minus close to the AB. Alright, so what's our focus is on the real solution. So please pardon me. There was a typographical error there, and there's nothing I can do to change that because this is a voiceover. Okay, so I will just solve it like that using the quadratic formula, just to prove to you that whatever we're going to get is going to be imaginary and imaginary solutions, and we will not need that at all. So just let's flow. We're supposed to have m squared minus m plus 1. That was what we ought to have, not m squared plus m plus 1. No, it was supposed to be a negative close to the m, but it was omitted, which is not good. But being that we're not going to use the solutions from here, we can actually ignore it. Just solving it to prove to you that you're going to have imaginary solutions. So imaginary solutions. So we're just gonna stop here because we weren't asked to look for imaginary solutions. So let's go to the one that is real, which is m equals -1. So since we have we've gotten two real solutions, so therefore we have two real solutions. And remember, we're supposed to have six solutions for m, which we already have right now. So these are the real solutions for m. And all we want to do now is to check if these solutions satisfies the equation m to the power of 6 minus m to the power of 3 equals 2. So we're just trying to explain that m to the power of 6, we are expected to have six solutions. Six solutions for this equation. We already have two real solutions, so we're left with 4, which we already have. So let me show you. So from this one, we already have 2, so making 4 because of the plus or minus. So there are 2 answers there. Here again, if we had solved it, we'll definitely have 2 solutions again, because we're going to use the quadratic method and we're sure going to have 2 solutions. So 2, 2, 2, making 6 solutions. So back to our checking. Here we're going to start with m when m is 2 to the power of 1 over 3. So let's put that in and see if it will satisfy this equation. So 2 to the power of 1 over 3 all to the power of 6 minus 2 to the power of 1 over 3 all to the power of 3 equals 2. So 3 cancels 6, 2, 3 cancels 3, 1. 2 to the power of 2 minus 2 to the power of 1 equals 2. 2 to the power of 2 is 4 minus 2 to the power of 1 is 2. And then we want to find out if it's going to be equal to 2. Yeah. All right. So 4 minus 2 is equal to 2 equals to 2. So perfect. It worked. We're going to look at another one when m is equal to -1. So -1 all to the power of 6 minus -1 all to the power of 3 equals 2. So when it's raised to a positive power, we're definitely going to have a positive answer. So it's going to give us 1 there. Positive solution. Then if it's raised to a negative power, I said a negative. Not really a positive, Jerry. I mean even number. The power is even, it's going to give you a positive solution. But if the power is odd, it's going to give you a negative solution. Please pardon me again. Okay, so we have 1 minus, in bracket, -1. 1 plus 1 equals 2 equals 2. So we can now see that when m is -1, when m is 2 to the power of 1 over 3, this both satisfies the equation m to the power of 6 minus m to the power of 3 equals 2. So if you've watched up to this very beautiful moment, it means you enjoyed the video. Despite some little errors, you still sticked till the end.